Go. Okay, the way we left off, I think it was last Friday, we went over this thing here, didn't we? Line of best fit. Remember that?
Yeah. Sure. Yes, sir.
And then here we are to this one here. Describe how to transform the graph of h of x equals h squared to obtain the graph of a related function. And we have this type of function here. Negative 2f of x squared minus 2 plus 6. So we want to transform the parent function, and parent function is going to be this looking thing here. So here's our parent function. This is going to be h of x equals x squared, and we want to transform this function into this one. So what will be your strategy for this? Any strategies? Anybody? What would you do? You're going to be given a problem like this on Wednesday's test. What are you going to do? Okay, you said to, what did you say, Randy? To the right 2, okay. She says it's going to move this thing to the right, so she says right 2 units. Okay, how did you come up with that? I think that's correct, but how did you come up with that? So she said she's very quiet here, she's very modest, but she said because negative 2 goes to the right.
Yeah.
And we had this, remember we had this thing, I'm just going to refresh, we had like, I think it was f of x equals a times x minus h squared plus k. Okay, that was like the vertex form. Okay, so I think we're okay with that. So this will be what? A transformation, right?
Mm-hmm.
Translation, excuse me.
Yeah.
Okay, what else? What does this plus 6 do? Up 6, he says up 6 units. And that would also be a translation as well, right? Okay, good. And so I guess we just have one more thing to take care of. What is this going to do here? What'd you say, Cheyenne? Reflect which way? So negative reflects about x-axis. Okay, and then one more thing. What does the 2 do? What does a 2 do? Somebody make an intelligent guess if you don't know what it is. Where's in your notes? What's a 2 do?
You know it.
Okay, so yeah, so what this will do is this will vertically stretch. Okay, vertically stretch. Stretch by factor of 2. And really to write this in the correct form, like in vertex form, this thing should be negative 2x minus 2 squared plus 6. Okay, and then what is the last thing you do on this after you've done this? Or maybe it's the first thing you'll do. What will you do? You go to your calculator. There we go, finally got my calculator working. Okay, first thing, how are your, pardon me? You're just practicing? Okay, good.
Thank you, I'm trying to speak. By mistake.
All right, first thing we have is we have x squared, right? Which is our, whoops, that's x to negative 1. I want to put x squared. We got x squared. Okay, so we're going to look like this. Oops, check all arguments. I got to do something. I did something wrong.
Second mode.
Second mode.
Down. It's like you can get out. Quit.
Second quit. Second quit. Yeah, second quit. I got it. Oh, that's what I did. Let me clear. Yeah. Okay, I got this now. Now we should be good. All right.
Now.
All right. And so the one we picked out was this negative 2, right? And we had x minus 2. And one thing you can do with these is you can kind of go through one at a time. The way it works out here, the best way to do it I found is to first reflect about the x-axis, and then the last thing you want to do is add the 6. But anyway, we graph this thing, we should see that. Okay, are we shifted to the right? Yes. Okay, Randy, you were right about that. Are we up 6? Cheyenne said we were turned upside down. Are we turned upside down? Is this thing made narrower?
Yes.
I mean, it's hard to see the narrowness, but it is the case. So test using the calculator, right? So anyway, that is yes.
What is the window?
Okay, the window, let me show you the window. That's actually a good question here, Lexi. All right. For window, what I would recommend, if you have some kind of window that was set, just go back to standard by pressing Zoom 6.
Zoom 6.
Zoom 6 gives you a standard window. And it's sort of like it takes you back to home base. Was that helpful to you, Lexi? Zoom 6, remember that. That's actually good. That's actually a very good contributing question to today's discussion, Lexi. Good job. All right. Very good, very good. Okay, any further questions on this? Right?
So what did you put for the other one, the X2, I mean the white one? Like the next equation that you put.
The next equation?
That one?
This one?
We go back to your calculator.
Right here?
Oh.
All right.
I just want to see if it works for me too.
So like on the desk,
Yes.
that's what we're gonna have to do. Like,
Well, you'll have to, what you're looking for, what they're looking for is this. I'll tell you what the answers are. That's another good question. They're looking for these as your answers.
Okay.
These are the answers they're looking for, okay? They're saying, okay, you have this and you got from this, so you're gonna have to describe what these different things do. The negative sign, the 2, the negative 2, the 6, okay?
Are we gonna write it out exactly like that?
Well, the thing about it is, like things, Jose, it'll be in your own words, which may not be exactly the words that I wrote here, but understandable according to your vocabulary and ability in Algebra 2 honors language. Okay? All right. Next. Gotta erase this for. Okay, now, here, we have a cable between two towers of a suspension bridge forms a curve can be modeled by a parabola. In the illustration shown, the unit of measurement is feet, vertex cable of the point is point P. Find the quadratic function that models the cable and state the function's domain. What do you think?
Let's see. We can.
Okay, remember.
It's 28. Yeah, I like the.
Okay, who said domain is pretty easy?
Yeah.
Right.
I didn't know it.
It was a young man's voice I heard. Yes. Yes, domain is pretty easy. Domain is pretty easy. That's why I was saying that. Domain is pretty easy. So what is our domain here? Does it say which form of domain to give? Interval or set, or doesn't really say. So let's go ahead and whatever kind of what do you want to give for our domain? What is our domain?
Maybe 24.
Okay, like this?
Yeah.
Okay, very good. Yeah, that was the first thing. That was a good call. All right. Okay. Then find a quadratic function. How are you going to find a quadratic function that models this situation? Again, we're talking about our XY coordinate plane right here, right? Actually, no. Actually, it's down here, right? Here's our origin right here. Here's X, Y. So here's 0, 2. Okay, good. What next? So Chloe says K is equal to 2, right? K is equal to 2. Or do you agree with her on that?
Yeah.
Okay, what else? That's a good observation. What else?
Check it for that.
H is what? H is 0. H is equal to 0. Okay. So now what's the next thing to do?
Find it. Find the slope. Maybe.
Anybody have any trace of remembrance on this thing? Yeah, so Rindy is taking us maybe to the next level here. Let's see. Let's see here. Okay. So Rindy makes a suggestion. Rindy, which point do you want to use here, Rindy? 2410. So how do we set up that equation for that?
Go 10 equals.
10 equals, okay. Ziggy, all right, good. A, and we have x squared plus 2, right? But x is what?
24.
24. Let's go ahead and change that to 24. So now subtract 2. So we get, I'm just going to work to the right. We have 8 is equal to 24 squared times A. Does anybody have 24 squared? It's 500 something? 576? 576 A. Then what? Divide by okay, and I think 576. So that's going to be 6, 7, right?
No, it's the other way around.
Yeah, you have to put the 8.
8 divided by 576.
So it's gonna be like 0.01.
Okay, yeah, you misunderstand what I'm trying to do. What did you get?
0.0138888.
0.0138. So that's 7 times 8 is 56, right?
Right.
Okay, and then 1, bring down the 6, 2, 72. So, A is equal to 1 over 72. So yeah, Cheyenne is right, but this is even more right, probably, right? So we'd say our function is going to be f of x equals 1 over 72 x squared plus 2, okay? And what's the last thing you're going to do for this?
You're going to change the f of negative 1. It's the... No, it's not, never mind.
Okay, what are you going to do? What are you going to do with this?
Okay, sounds good.
What are you going to do to test this function?
Put it in the calculator.
Put this in the calculator. Very good. Very good. Yes. Now I tell you, yes, you do. In fact, I'll tell you one thing that's really good about you, your family, or somebody. You make heck of good like notebooks and stuff like that. I go to the store and see these. Nope. Mead. You ever seen the Mead?
Oh, Dad makes notebooks?
Yeah, you go with
The
Mead.
need brands of like school stuff.
Oh!
That's my last name.
You're-
So like,
Are you related to that?
You know? Hey,
somehow.
I think I was related to the solid peroxide brand.
That was? All right. Yeah, well, congratulations. Yes. All right.
What?
So how do we, yes, thank you. I'm too busy being enthralled by my own sense of humor. Here.
You know, Lily Harris is,
don't get it.
Lily Harris is related to Ulysses S. Grant.
No, I didn't know that.
Yeah.
Why?
Yes, she is. She found out on,
I'm gonna go ahead and,
she found out on Ancestry.com.
wow, okay. Very good. We'll find about, okay.
Yeah, I can't.
Well, I will talk to her about that yesterday. I tried to, today in financial math, we played a Kahoot game, and she did pretty well. I tried to promote her to pre-calculus, but she didn't want it to go there, so. Can't force her.
I have to sneeze.
My mom was gonna be a
Oh, we gotta look at it.
My mom wants to be a
Yes, this is Haley's idea. So is this it right here? So let's go to table view and see if we have everything here. We have 0, 2, right?
Yes.
That's right.
Guys, how do you put it?
Do we have,
Go 24.
What?
Can you go back to the...
let me see, that doesn't look right. We're supposed to have 2410, okay, 2410. So we go down to 24, right?
Yeah. Shouldn't it be like,
There it is, right?
it should be like this, or it should go like this?
So...
Yeah, this is extra wide.
Yeah, it's like this.
Yeah.
Whoa.
And there we are
It's
at
like the what?
negative 12.4, right?
No.
Or negative 24, negative 24, right? We want to go to negative 24.
Like always.
I do.
There we go, negative 2410 and 2410. Okay? Is everything good with this? Okay. Let's go on to the next one here. Okay. Yes.
I don't have any numbers like they, like I have to enter them.
Oh, okay, here, let me show you.
Why we did it?
Like,
Or why we did it.
Y equals, I mean, alpha
What
y.
I do is math.
I know how to do it. I just don't know why.
No, just do alpha y equals. And hit enter. That was too complex.
I don't know.
All right, next.
That's school.
Okay, let's refocus here. Okay, you guys been helping each other with calculators and stuff, give a good idea. Find the inverse function, f negative 1 of x for the function fx equals negative 1/3 x plus 5. Again, I made this is very similar to one you're going to see Wednesday on your test. Yeah, your notes, now I want you to, you can use notes, but I really want you to restrict your note usage to the review plus the graphical transformation. Now, graphical transformations table I had you write down. Those two things should be good enough for the whole test. Because if you have access to your whole notes, that's not going to be efficient to be flipping around through everything. Right? But with that, I'll leave that up to you, but that's my recommendation. All right. Okay. So you're working this one out now, I hope.
Yeah.
Work that out. We'll go over it.
You saw about the quick trip already? Did you stop by the quick trip every day? The gas station?
Yeah, the Kelly's Exxon.
Oh. Never mind.
Oh yeah, well, I have, yeah.
Oh.
Yeah.
I see it. I get you now. I understand your question.
Yeah. I was just like,
Mr. G, I was doing the chant over there on the other side, and they were giving me bad looks.
Yeah, that was not, I told you to be careful.
Yeah, they're pretty trashy. They're pretty mean. You were saying it pretty loud. I was saying it pretty loud.
What were you saying?
I can't even spell it. UGLY. You ain't got no you ugly. Mr. G told me to say that.
That's cool.
All right.
Stop.
she's caught.
Wow. That makes the face.
Well, this video is not going to go up. You probably today. All right. All right.
Now she knows.
You should get like y equals negative 1/3 x plus 5. Did you get that far? That x equals negative 1/3 y plus 5.
So you just switch it.
Subtract 5. So you have negative 1/3 y equals x minus 5. Then you divide by, or actually you can multiply by negative 3, right?
Yeah.
So that'll cancel that out. So you get y equals negative 3x plus 15. Does that look right?
Yes.
Did you test that in your calculator too?
Nope.
I'll do that one next time. Yeah. Do negative. Oops. Negative 1/3 x.
Yeah, I think it's right.
X, let me see if I got it right here. It's x plus 5 plus 5, and then we'll do negative 3x plus 15. See if they look like inverses of each other. And if they're inverses of each other, they reflect about the line y equals x. Check it out. Now, does that look like they're inverses of each other? Maybe, but the proportionality is a little off. How do we get proportionality, perfect proportionality in our calculator? Zoom what? Zoom square. Zoom 5. Zoom 5. Okay, so now it looks like it's perfectly proportional, right?
Yeah.
Can you go back to the white?
Zoom 5.
Yeah.
No, I mean,
I think I just
you
said
that
that.
line is.
Look pretty good.
Okay, what?
Are you asking me that it reflects over?
No, I'm asking like, Let's
I
see.
think this retainer is off the last bit here. I'm about to do it.
Okay,
It's the parent function. Just put it right in the space like I read.
Like when we do a scatter plot?
Oh,
I never understood those.
I'm not gonna do that.
all right. Everybody good on this?
Yeah.
Okay, good.
Oh,
And I think that might be the extent of our review. Let me see if we got anything else left here. That's all the review we have. Okay, here's what we're going to do with the rest of today. We're going to start talking about absolute value functions. And tomorrow what we're going to do is we're going to have a Kahoot game that reviews all this stuff. All right? And then we're going to do more on absolute value functions and have our test on Wednesday. So we're sort of breaking things up a little bit. So we're going to be working on absolute value functions the rest of the day. Okay? Can you go to your notes on absolute value functions, and it's going to be this one right here. Graphing 2.1. So this is really starting on the next module, really. Graphing absolute value functions. Essential question: how can you identify the features of the graph of an absolute value function? And we've talked about that a little bit here, I think, in class. Does anybody know what the graph of an absolute value function looks like? Yeah, so Rindy's going, Rindy's going like this. That's what the graph, so a V shape is what the thing looks like.
Like value.
Like value, yes.
No.
All right. Okay, and this really tells what it is. Absolute value function can be defined piecewise. And piecewise function is something that's written like this, where there are two different rules for different intervals of the domain. So x, when x is greater than or equal to 0, but negative x when x is less than 0. And so the function simply returns the number. When x is negative, the function returns the opposite of x. So we have complete the input-output table for f of x, and using the rule here, it's if we take negative 8 for x is less than 0, we take negative x. Well, what's negative 8? Negative 8. And negative 4 is 4. And then now we're to the part of the rule where we put x when x is greater than or equal to 0. So we just put x, 4x. So that would be following this piecewise rule. And a piecewise function is one thing we'll probably go more into, those of you taking pre-calculus and calculus. We use this a lot in calculus, actually, piecewise functions. Okay, so that's all there is to it. Does that make sense? I hope. Yes, maybe. All right. Next, we have plot the points you found on your coordinate grid. Complete the graph of the function. And over here, if you remember the graph, we had negative 8, 8. We had negative 4, 4. We had 0, 0. We had 4, 4, and 8, 8. And so the thing will look like this, if I could draw it right. So that's what it'll look like. Now, it says examine your graph of f(x) equals absolute value of x. Complete the following statements about the function. the graph of f(x) equals absolute value of x is symmetric about the what? About the, where do we have symmetry here? Y-axis. And therefore f of x is a or an what? The choices are odd or even. Is this odd or even? It's an even function. And so the domain is going to be, what is our domain going to be? This thing here, right? And what is our range going to be? Okay, so that's really it. Do you have questions about that? No, pretty good. Okay. Okay. You need me to stay here a little bit?
Thank you.
Just a little bit.
Okay. Okay, I don't want to do this reflect thing here, okay? Now, the last thing I want to talk about today is this part right here, that we're talking about transformations, and here they give we're going to look at transformations, absolute value functions. And mostly what I want to see here is to use the basic format f of x equals a times x minus h plus k. Now, b and a b is a divisor of a essentially. So you could write this out as 1 over b like this. You see that? But I just like to leave everything in terms of a, because this is directly being a coefficient. We can just make this a. It can just make our life easier that way if we do it this way. But you see this takes the same format we use for the quadratic function, and also will be for other functions throughout the year. So basically what you've learned is going to carry on to apply. And so predict what the graph of each function will look like, then sketch the graph of the function. The graph of g of x equals absolute value of x plus 6 will be the graph of f of x equals x, translated which way or how? What is this going to do here? What do you predict, Bryce? Okay, translate up 6 units, right? And then we could graph this thing. We could take what I'm going to do that you're not going to be able to do as well. We can translate up 6 units. How do we do that? Go like this. Oh, the magic of smart technologies. All right. And the graph of g of x equals absolute value of x minus 4 will be the graph shifted down 4 units. And so now we're taking this thing, we're taking it down 4 units like this. Okay? So Let me see if I can do something with this. You know. I want to see what I can get away with here with this pen. Okay, let's see. Clone. Oh, look at this. There we go. Look at. All right. Questions on those? And I think that tomorrow we might start on the left-right bit. We'll just save that for tomorrow. Anyway.
I think today was a very productive day.
It was very, thank you. I did too.